Hello and welcome to Mr. Tompkins Ed Tech. This series of videos provides work solutions for the GCSE Maths Topic Test produced by AQA. This video is Indices. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. Okay, section A is for calculator, so you can use your calculator for these next few questions. And question 1 says use your calculator to work out root 33.64 all divided by 19.8 plus 9.2. Now, don't be cheap, get yourself a proper calculator for your exam. I'm using the emulated version of the Casio FX83 GT here. The 85 is nice as well with the solar panel on it. Or if you're sticking around for A-level maths, you might want to spend a little bit more and get yourself a Casio ClassWiz. A little bit more expensive than the 83 or 85, but it will see you all the way through to A-level. So assuming you do have a decent calculator, you should just be able to type it in exactly as it appears on the page. Now this is a quotient, so I'm going to use the fraction key first off to get my two parts, my numerator and my denominator. In the numerator I'm going to type in the square root of 33.64 and then press the down key to get to the bottom part, the denominator, and type in 19.8 plus 9.2. And that comes out to 0.2. Question 2. What whole number power of 2 is 16,384? Okay, so I want 2 to the power of something is equal to 16384. Now we don't know enough maths yet to solve that equation as it is, so what we're going to do instead is going to use a trial and error approach really. What I could do is I can type in 2 into the calculator and then times that by 2. So that 2 is 2 to the power 1. 2 times 2 is 2 to the power 4. Because I've got the answer, I've used the answer key though, if I press equals again, you can see that it feeds the 4 back in and times it by 2. And that will give me 2 to the power 3. And if I press equals again, I get 16, which is 2 to the power 4. And I can keep going, and I just need to count how many times I press equals. So I've pressed it 4 times so far. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 presses. So that would mean that that is equal to 2 to the power of 14. Okay, again, I can just double check that now on my calculator. 2 to the power of 14. Yeah, that is 16,384 as we thought. Question 3. 2 to the power of x times 3 to the power of x is 1,296. Work out the value of x. Again, this question is going to be a bit of a guessing game. Let me try. Well, I know it isn't 2 to the power 1, but I'll just write that down for good measure. 2 to the power 1 is 2. 3 to the power 1 is 3. 2 times 3 is 6. That's obviously not going to be high enough. If I got 2 squared times 3 squared, 2 squared is 4, 3 squared is 9, 4 9s are 36, that's also too low. What about 2 cubed times 3 cubed? That's going to be 8 times 27, isn't it? 8 times 27. Again, it's too low, it's 216. What about 2 to the power 4 times 3 to the power 4? 2 to the power 4 times 3 to the power 4. Oh yeah, there we go, 1,296. 1,296. So what was the question? Work out the value of x. So x equals the number 4. Okay, question 4. Work out 2 to the power 7 times 3 to the power 5 divided by 6 to the power 3, all raised to the power of a half. Again, it's a 1 mark question, so we just really need to type it into the calculator and work out the answer. And again, if you've got a decent calculator, that shouldn't be too much hard work. So let's just type that in. I'm going to put some brackets in first, so a bracket first, and then I'm going to use the fraction key to create the fraction. And then I'll type in 2 to the 7 times 3 to the 5 in the numerator, and then press down, put in the 63 in the denominator, and then tap right, close the bracket, and then put the power of a half in. Okay, now it looks like it does on the page. I can press equals, and that gives me the answer of 12. There we go. Question 5. Raj and his sister Zia are both at secondary school. Raj is 3 years older than Zia. The sum of the squares of their age is 369. How old are they? Okay, so we don't know either Raj's or Zia's age, but we do know their age relative to each other. So Raj is 3 years older than Zia. So let's say that Zia has an age of x, then Raj is going to be 3 years older, so that is x plus 3. So then we're told that the sum of the squares of their ages is 369. So the sum of the squares means take their two ages, square them, and add them together, the sum of their squares. So I get x squared plus x plus 3 all squared. Okay, and then that is equal to 369. Now, it's perfectly possible to multiply all this out and collect like terms, form a quadratic equation in x, which we can then go on and solve, and that would give me my value of x. But that is a lot of work for 2 marks, and I don't think that is the way they're expecting you to do it here. And this is a calculator paper, so I'm just going to try various values of x and see if I can find one that works. So I'm going to kind of do a trial and improvement table. So value of x, and then work out what x squared plus x plus 3 all squared is until I get the right answer. So let's try x equals 5. What's 5 squared plus 5 plus 3, 8 squared. 5 squared plus 8 squared. That gives me a value of 89, which is too low. Let's try a bigger value of x. Let's try 10. What's 10 squared plus 13 squared? Getting warmer. That's 269, 100 short. So let's go a little bit bigger. Should we go for 12? Let's try 12. What's 12 squared plus 15 squared? 369. Excellent. Okay, so x is 12, then 12 squared is 144, and 15 squared added to it is going to give me 369, which means that Zia must be 12 years old, and Raj is 3 years older than her, must be 15 years. Okay, like I say, you could have solved that and done it the long way, but for 2 marks, I'm not going to go to all that effort. Okay, done. Question 6a, write 11 to the power 13 times 11 to the power 3 divided by 11 to the power 7 as a single power of 11. Okay, so these numbers all have the same base, so we can use the laws of indices to combine their indices together into one index. Multiplying 2 numbers with the same base, you add the indices, so that is going to give me 11 to the 13 times 11 to the 3 is going to be 11 to the power of 16. And then dividing 2 numbers with the same base, you subtract the indices, so 11 to the 16 divided by 11 to the 7 is 11 to the 16 subtract 7, or 11 to the power of 9. Okay, right, 4 to the power 3 to all to the power of 5 as a single power of 2. Okay, so I've got 4 to the power 3 all raised to the power of 5, but I want to write it as a power of 2. Now 4 in the middle here, 4 is 2 squared, so I could just replace that 4 with 2 squared and then fit that in. So then I'm going to have to cube it, and then I'm going to have to raise it to the power of 5. So it's 2 squared cubed raised to the power of 5. So I've got an index of an index of an index here, so I need to multiply all those together. So squared times cubed, multiplying those two together, it gives me 2 to the power 6, and 2 to the power 6 times 5 is 2 to the power of 30. So as a single power of 2 is going to be 2 to the power of 30. Now like I said, you've got a calculator on your desk, so you could just double check that. 2 to the power of 30, very large number. What is 4 to the power of 3 all raised to the power of 5? Which is very large and same number. Okay, so that works. Question 7, write 224 as the sum of 2 cube numbers. So I'm going to have to write 224 as the sum of 2 cube numbers. So something like x cubed plus y cubed. You've got to come up with 2 cube numbers that add up to 224. So what are the cube numbers? Cube numbers are 1, 8, 27, 4 cubed is 64, 5 cubed is 125. The next one is going to be 6 cubed. 6 cubed is 216. So it's going to have to be 216 and something, isn't it then? 216 and 9. Sorry, 216 and 8. So it's going to be 2 cubed, which gives me the 8, and the 6 cubed, isn't it? 2 cubed plus 6 cubed is 224. Excellent. Right, moving swiftly on. Section B, 10 minutes non-calculator. Put your calculator away. So here we'll have to not use our calculator for this part, so we have to do it from using our laws or our knowledge of indices. Right, question 8 says, estimate the square root of 90. Okay, so if you know your square numbers go 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, we've got 2, 7, 8 is 64, 9 squared is 81, and 10 squared is 100. So they're all my square numbers up to 100. So the square root of 90 lies between 81 and 100. So the square root of 81 is 9, and the square root of 100 is 10. So the square root of 90 is going to be somewhere between 9 and 10. So I'm going to estimate it to be halfway between 9.5. Now I'm sure the mark scheme will have a range of possible answers there. And remember, we only need to estimate it, we're not calculating it exactly. So I think that will be close enough. Similarly, between which two integers does the cube root of 80 lie? Again, you should really know your cube numbers for your exam as well. So they go 1, 8, 27, 64, 125, don't they? So the cube root of 80, it lies between these two, 64 and 125. Cube root of 64 is 4, cube root of 125 is 5. So your answer is going to be somewhere between those two. Okay, so cube 80 is going to lie between 4 and 5. Question 10, write 100 million, or the root of 100 million, as a power of 10. A million is 10 to the 6, isn't it? So 100 million is 100 times 10 to the 6, and we're square rooting that. So 100 is 10 to the power of 2. If I times that by 10 to the power of 6, I'm going to get 10 to the power of 8. And square rooting something is the same as raising it to the power of a half. And now I've got an index of an index, so 8 times a half is 4, so that's the same as 10 to the power of 4. 10 to the power of 4. Question 11. Solve the equation x squared minus 1 is equal to 48. Okay, first off, moving that over there, I'm going to get x squared is equal to 49. So then x is equal to the square root of 49, which is equal to 7. But don't forget, when you square root, you get two solutions. You get a plus and a minus solution, because positive 7 times positive 7 is 49, but also negative 7 times negative 7 is 49. So you're going to get two solutions here. And if you miss one out, you'd have lost a mark. Question 12. Tina says the difference between any two consecutive square numbers is always odd. Is she correct? Yes or no? And give your a reason for your answer. So let's start by saying our numbers are, what are they? Let the first number be x. And now if they are two consecutive numbers, then the next number is going to be next to x, isn't it? It's going to be x plus 1. So I've got two numbers, x and x plus 1. Now, the difference between any two consecutive square numbers. So if I've got two consecutive numbers, x and x plus 1, then their squares are going to be, their squares are x squared and x plus 1 all squared. And then if I want the difference between those, that's one take away the other, isn't it? So if I have x plus 1 all squared and I subtract x squared, what do I get? Okay, well, to work that out really, I need to work out what this part is first. So I've got x plus 1 all squared, so I need to remove the brackets there. Remember, x plus 1 all squared is x plus 1 times x plus 1, which you can either multiply out using the identity, or claw or foil, or smiley face method, whichever one you like. So we're going to multiply that out, and then we're going to subtract off our x squared term. Okay, so what am I going to get? X squared plus x plus 1 minus x squared. Okay. So straight away I can see my x squared there and my x squared there are going to cancel. X squared take away x squared is nothing. So that's going to leave me x plus 1. X plus x is 2x. And so my final answer is 2x plus 1. So the difference between my two consecutive squares is 2x plus 1. Now, why is that always odd? Well, let's assume that x is even. Then 2 times an even number is going to give me an even number. Plus 1 will give me an odd number again. But then again, let's say x is odd. 2 times an odd number is always even. And then add 1 again, you're going to get an odd number. So I can say 2x is always even. So 2x plus 1 is always odd. Okay, done. Or at least it would be if I'd have ticked the right box. Is she correct? The difference between any two consecutive numbers is always odd. Yes, she is correct. That's what I found. Okay, now I really am done. Question 13. Estimate the value of x when 3 to the power of x is equal to 25. Well, what have we got? I know that 3 to the power 1 is 3. I know that 3 squared is 9. And I know that 3 cubed is 27, which is a little bit more than 25. So I imagine then that 3 to the power of something slightly less than 3 is going to give me 25 then. Let's say x is 2.9, something like that. I think that sounds about right. Question 14. A and B are whole numbers greater than 1. Work out the different pairs of values for a and b for which a to the power of b is equal to 64. Okay, so a and b are whole numbers greater than 1. Two different pairs of numbers for a and b such that a to the power of b is equal to 64. Okay, so I need to take one number, raise it to the power of another one, and get 64. Well, I know that 64 is 8 squared, so I could have a is equal to 8 and b is equal to 2, and then I'd have 8 to the power of 2 is equal to 64. And I also know that 64 is 4 cubed. So my second pair could be, if I take 4 and I cube it, I'm going to also get 64. Okay, done. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.